Okay, we continue in another video. So we are doing the wavelength calibration step. We took one helium-neon arc frame, one comparison spectrum. We used the task identify in a previous step to obtain the solution from pixel to lambda. Now, in short, what's going to happen, we'll see how far we go, but we use another task called re-identify and feed coords. The re-identify task finds basically applies it to every 10 lines along the spatial axis, and then with feed coords afterwards you create a 2D map for the 2D frame. And then after that is done, you use another task called transform, which transforms using the map your 2D file in 2D spectrum from pixel units to a spectrum in wavelength units. In it, first you use a transform back on the arc frame, on the comparison frame, the helium-neon arc frame, and then you use a transform again on the object on the quasar frame. And once you're done with that, the wavelength calibration is done, and your 2D raw frame is ready for background subtraction and for extraction of 1D spectrum. Okay, so let's go and do it here. First, the re-identify task, par, re-identify. Enter. Now let's reference image, and it is the same image that is to be re-identified. Yeah, tray, no. Checking. We did C radius. What did we do? It was 6. So it's here. Oh, here it is. The radius is 6. And the threshold also has to be the same as identify. It's 10. Yeah. And then add feed. No, this is the database. User coordinate list. Match. Okay, so now you can notice that it says fit dispersion function interactively. The re-identification, we say no. We say no. I want to copy this. we go and execute it. There's the wrong output. Copy this one. So what does this output mean? The columns are the image data, pick, shift, user, shift, C, shift, RMS. Okay, the RMS, let's check. 0.3. Okay. Now we can do the feed chord step. So let's do that step as well. We do e-par feed chords. And we enter. It's the name of the chord. Name of chord entry in database. Okay. Interactive, yes. Combine input coordinates, no. Deviations. Deviation. Deviation.tp. Chebyshev 66. Okay. It's all good, and we'll take and then we'll execute it. Feed helium neon interactively, yes. Yeah. Okay. This is well. Mhm. So now I have my beautiful iron font. XY representation can be called out in a green screen by typing X, X, Y, Y, R. Let's see if I remember. X, X, Y, Y, X, select. Right. Now it is residuals versus Y. By pressing the wrong button. Okay, because I have to do column first. Okay, I have to look. Okay, I remembered exactly how to type. I put here wrong. So you type in directly, type no column necessary, and keep typing all the letters. So if I want to do X, Y representations, and I do X, X, Y, Y, R, and it brings it. And then I will delete the H points by positioning cursor on first and last columns and pressing D and X. And I will take snapshot. And then press F for new fit. And then for XR representation, I do XXYRR, XXYRR. And here, deleted points by D and P. Delete points by D and P. I don't know, maybe this is way off, but maybe this one is. Okay, and then F for new fit. And YR representation would be X, Y, YRR. All right. And then delete points by D and P. Okay. These ones are already deleted. And then I click F for a new fit. X, Y, R. This is good. Okay. I'll just do F again and then Q. I forgot to take a picture, but okay, I'll take a picture here. And now, right coordinate map to the database. Yes, let me copy it. Yeah. Right. Okay, we're done. Well, let's study the output. I'm just correcting my log file here, but let's read. So it is saying that now this is the helium near arc map for access to image features. This is the order of Chebyshev fitted coordinates at the corner of the images. So now we can I have a few minutes. Are we gonna do it? Okay. Now we are gonna do the transform on the arc frame. So you part transform. Enter. And here I have to the input is the images to be transformed, and the output is the image of output images. So because the output image is transformed, I want to name it something else to keep it reproducible. So this is the input image. See, in database now we have the feed chords mapped. So input is this, and output, what should we name? I guess T for transform. It's gonna be BTFTT. Okay. Um, and then feed names, name of coordinate feeds in the database. Names of the user coordinate maps in the database to be used in the transform. If no names are specified using the no strings of world, no. Here's my mm. Um, mm. So here is the parameter file for the transform because we produced a solution with feed chords which is stored in the database right here, FC. And now we're trying to transform the file, the arc frame, using the correct name of coordinate fits the database. Okay, and then we can execute. Mm. Okay. Um, so I got word I was doing something where it's correct. So in this case, this is a coordinate feed name. So the feed name is this name here. So the feed codes procedure output is the coordinate feed, a map of coordinates. And in the output, it says the name. So I inputted here. Name of coordinate fits in the database. E parse transform. This is correct. No, why is it doing? So it's the same as the input. Everything else is the same, but I want to make sure that I correct. And then go enter. Now it's supposed to work. So let's copy this. And it's telling us what it's doing. Transform helium neon arc to helium near arc. New name, visit second TNC and consider flux per pixel. User coordinate transformations is interpolation spline 3. Okay, and the dispersion axis, 1 along lines, 2 along columns, 3 along Z. So our dispersion axis is 2. It's along the columns. And then enter, um, to enter. Okay, it did it. We can see what happened. All right, I was looking at the log file too. Close this. And then here is our helium arc. I can open it in DS9. I have to hurry. It is trimmed. And then this is transformed. Okay. Good. So you can see, if you can notice that they switched. But anyway, we are done with transforming the uh, arc frame. And now I'm just correcting my log file. And then we do another transform, but of the quasar. So our quasar is, so let's do again EPAR transform. And now we give it the QSO 121. Okay. And the new name be FTT. Everything else is the same. Okay. And then we execute it. It's working on it. And again, all copies is into 2, enter. Because our dispersion axis is along the column, I can want to adjust my log. It was a little bit incorrect. This out of sequence where I recorded the steps. This is done. And now also the science frame is calibrated. Now we can visualize it. What? This is the non-calibrated with a 1T at the end, and this is wavelengths calibrated.